Okay, we continue the analysis by going to state 2, and we're up to the Q3 question, I guess. You should, of course, have already thought about that question. If you haven't, stop and think about it, work out what you can. In any case, we go to pressure P1, temperature TF. In other words, we've raised the temperature to T from T0, and now we're going to raise it to TF at constant pressure. So at constant pressure, again, number of moles and now pressure being constant, the relationship is just going to be V2 over V1 equals TF over T. Start at temperature T, volume V1, end up at temperature TF, volume V2. So that volume V2 is TF over T multiplied by V1. Now we haven't specified volume V1, but it's the same as volume V0. Of course, we haven't specified V0 either. So we're going to work that out in a minute, but let's just stay with this for a minute. So that the change in volume is going to be what? TF over T times V0 minus V0. And that, you factor out the V0, you get this expression. We can put that over common denominator. We will eventually. But now the delta V12, and that's a 1, 2. I don't know if that's very readable. It doesn't look too good from here. It must look terrible from there. But the delta V over the number of moles, because that's what we want now, the change in volume per mole, is just then, well, this expression divided by n. And I put the n in the denominator here. Now, what about this V0? Well, V0 is nRT0 over P0. Now, we were given T0 and P0, so those are quantities that we presumably know. V0 over n, then, well, is just the same expression except the n is gone. So V0 over n is RT0 over P0. So now we have the volume per unit, or per mole, in terms of just T0 and P0, R being the universal constant, and we don't have to add any information to the information we assume we have. So that V0 over n is replaced by RT0 over P0, then we do the common denominator thing and we get this expression. Okay, so the next question is how much heat flows into the system in order to accomplish this. Well, again, analogous to what we did before, now we have 5 degrees of freedom, but we also have to do the work of expansion, which is an additional r. So if we add r to 5 halves r, we get 7 halves r. And the delta Q 1, 2 would then be n times 7 halves r times TF minus T. As before, we divide by the n to get the heat per mole, and we end up with this expression. Fairly straightforward. Gets more complicated, but so far to this point, you should be in pretty good shape with this symbolic analysis. And again, reminding us that we want delta V per mole. That's the delta V over n.